if we look at our 4 sites, so Bancheng, in this case, had 15% of metal objects were grave goods. And then the deliberately shaped, I should say not metal, copper base. The deliberately shaped copper base material is a substantial portion, and this darker area is the amorphous. And that looks similar to what's going on in Banpakdo and Bantong and even Donglang. And so we think this is a general pattern. And just by way of comparison, it's hard to get this kind of data from other sites, but there's a little bit of data from Manonwat, just the bronze period, and we have 96 objects out of 1,319 copper-based objects at Manonwat being reported, but no differentiation in here of shaped versus amorphous. But I think you can see that basically the distribution of outside burial and inside burial copper-based metal was the same, comparable at Banonwat and at Bancheng. Okay, so now, as archaeologists, we've described what we recover, we classify it, then what? How do we, we're really aiming for here, we want to make inferences about society. So we have a lot of methods, context, typology, petrography, depending on the material. But there's another critical piece to interpretation, which is this piece right here, the theoretical framework. The theoretical framework, it's like our glasses. If we are farsighted and are wearing nearsighted glasses, we're not going to see properly. So choice of the framework is essential to properly interpreting our sites. Oh, why is this doing this? Okay, there we go. Okay, so metal is among the kinds of material remains that archaeologists can study as crafts. There's pottery, many different crafts. This is mostly what we recover in terms of manufactured products in the archaeological record. And there's now a lot of theory available for interpreting things like metal as parts of craft production. There's a lot of it, tons of literature. And we have only just started applying these ideas in the Southeast Asian context. However, 20 years ago, Vince Piggott and I co-authored a publication that pointed out that when you systematically look at the evidence available then, there was a particular kind of specialization called community specialization that was in evidence in the way the metal was smelted and mined and smelted and produced, and then the next step, the manufacturing step. All the evidence pointed to this being done on the basis of communities, not on the basis of centralized workshops. It's very interesting. This is a major contribution of Southeast Asia to understanding early metallurgy. Okay, so now we all love technical studies, but why do them? The most important thing technical studies can tell us is aspects of the life history of objects, how objects were made, how they were used, and from that evidence of how objects were made and used and how things were traded, this can tell us about the technological and economic relationships of the past. So again, going towards our wanting to make inferences about society, technical studies are one step to do that. So, and technical studies are essential for studying the chaîne opératoire of how objects were manufactured. The Penn program applied technical analyses to representative samples and examined the manufacturing evidence to characterize technological choices and systems. Of the 639 or 40 objects, 176 had metallographic analysis. That's 33% of the copper base assemblage. That's a very substantial sample. 55 elemental analyses on 52 artifacts, and these little things I'm going to show you later called prills. 10% is pretty good. Sample of the copper base assemblage. And then there's a much smaller sample of lead isotope analyses, 14, only 2.7. So we should think of the lead isotope work as like a pilot study. And there's one other type of analysis that I'm not going to talk about much today called hardness testing. And again, that was on a substantial sample. So we have a very well sampled assemblage for technical analysis. Now, just to give you a little sense of metallography, the steps involved are you very carefully remove a sample from your artifact using a kind of saw that does not distort or heat up the artifact, because you don't want to add new changes to the metal. Then you put that little piece in something that becomes this kind of plug. It's called a resin. And it's heated, and this little contraption here will make these little plugs with your metal. Then the next step is incredibly laborious, which is why many students learned how to do this. They did all the work. You have to polish in a series of grits the sample, and finally on a different kind of polisher. And then the objects, the polished samples are etched with acid and examined under the microscope. And after all that work, you can get a picture like this. So metallography is the backbone of metals analyses. And I'm not going to go in detail here, but I just want to point out that metallography helps a little bit with understanding alloys. So when you have this kind of gray stuff in between these lumpy things here, that only happens when there's been 5% of tin or more. So you get a head start in understanding your elements when you do metallography. Another thing that the metallography shows is evidence of what happened after the object was cast. Was it just left at what they call as cast? Or was it hammered? Was it heated up and annealed? And so this particular image shows kind of the flattening of the dendrites, which shows that this particular artifact had been hammered. But with our large sample, 177, we found that most of the copper-based artifacts were not hammered or annealed. They were left as cast. That's very interesting because it's totally different than what's going on in Europe at the same time, where hammering and annealing was the standard practice. Okay, so the 52 elemental analyses of artifacts, we included a little less than half of the identified artifacts, but 29 of the unidentified, including the amorphous, the flat, the wire rods. Of the 52, 48 were alloys, mostly tin bronze. So again, that's a very significant, and the significance of this will be clearer in a slide or two. 4 were impure copper. Impure copper might have some trace elements, but they're less than 2%. So the elements might have gotten in there in various ways other than a deliberate alloy. There are some unusual alloys with a little arsenic, a little antimony, and these are mostly in the early period, which suggests that there was more experimentation in alloying going on in the early period, and then they got more standardized over time. The lead isotope analyses were done under a project by Ollie Price, the Southeast Asian Lead Isotope Project, or CLIP. And I'm just giving you a sense of, fancy equipment. That's as much I will say on that. But also, we have, this isn't quite, oh, yes, it is. Okay, so there are 3 mining or metal smelting sites or regions that have had some study that were used during prehistoric times. We have the Kawang Prajan Valley in Lopburi. We have Pulon, which is at the border between Nong Khai and Loei. And we have Sepon in central Laos. So Ollie was able to get signatures of the kind of lead isotope signature characteristic of those three mining sites, and then compare it with our sample and many other samples, not only in Thailand, but in Southeast Asia. And while we're looking at this, I just want to point out the Camuan tin deposits, which are Nakhon Phanom. And these have not been studied, but I think this is a very high priority for archaeometallurgy going forward. Okay, so where did the Bancheng 14 lead isotope studies relate to these different mines? We kind of thought, oh, well, Pulon, not too far away, they're most likely line up with Pulon. Well, that was a big surprise. Okay. Okay, let's go back to this spear point. This is such a wonderful artifact. Unfortunately, I had thought it was going to be in the Bancheng Museum and we could all go see it on the 28th, but I have since learned that it is on temporary exhibit in Bangkok at, I think it's the Science Museum. So, darn, I really wanted you to see this. This has so much information, this piece. First of all, it's a tin bronze. So definitely alloying, people are alloying. It has been left in the annealed state, meaning it has been left after it was heated up, which means it was soft. The metal was soft. The copper most likely came from Sepon. So, big surprise for us. We don't have an analysis yet of the ads for Vulcan. You've heard a lot about Vulcan. But the bracelets, or 1 or 2 of the bracelets, is also from Sepon. So there are 3 artifacts in the Bancheng early period that can be traced, their copper can be traced to Sepon. None of the rest of the 14 analyses came from any other known source of the copper. This is just a picture of where the spear point was found in a flexed grave in the lower early period. So this is what a lead isotope analysis looks like. The green here is the Kawang Prajan Valley signature in Lopburi. The yellow, very broad, is the Pulon signature, and the red here is the Sepon signature, and those 3 green circles are the 3 artifacts from Bancheng that can be linked to Sepon, and then you can see the other green circles are outside of any known copper source. Oh, let's do this. Okay, so again, just to remind everybody where Sepon is. So the bronze spear point and Vulcan's bangles came from Sapon, at least the copper did. And of course now the question is where did the tin come from? So that is really quite an interesting result. Now this is to clarify how important this is. Similar work done from Bononwat. First of all, Bononwat, the early copper-based objects were not tin bronze. At least actually the sample's very small, but the small sample that has been studied shows that they were copper, not alloys. And the few that have lead isotope signatures that can be related to a copper mine come from the Kawangpajan Valley area. So what we are getting a picture of, a fascinating picture of how the Sakonakon Basin was relating to a different copper source than Bononwat and the southern northeast Thailand to central Thailand. So this is just the beginning of a picture of the social networks, the economic networks, the technological networks are much more complicated than, and much more interesting than we had thought going into this. The study of metal objects is just one part of an archaeometallurgy study. Equally important is the study of the manufacturing equipment and byproducts. So the production components can reveal all sorts of interesting relationships, cultural choices, social values, and one of my favorite artifact types from Boncheng is the crucible. There's a particular technological treatment called lagging that is really so well represented in Thai prehistoric archaeometallurgical sites. Can you see the kind of the little ridges here and this kind of encrusted sort of thing going on here? And here, you see it here, and it kind of peters out here. That is a quartz-rich material that was probably combined with some clay, and after the crucible had been made and fired, this material was lined, 5 minutes, my God, lined the crucibles, and that made that the crucible could be reused, and it protected the crucible from deteriorating while it was being used. This is a signature characteristic found all over northeast Thailand, and also a little bit in central Thailand, according to Ajahn Surapan Natapintu. So this is really a very interesting aspect of Thai prehistoric archaeometallurgy. And I told you I was going to show you prills. So also in crucibles, you can study the remnants of the metal stuck in the lagging and find out where they were alloying. And we believe they're actually doing some of the alloying in the local villages. In fact, the manufacture of final products took place at most local villages. Again, a very unusual aspect to Thailand's archaeometallurgy. This is just a lump of amorphous, which also shows that our amorphous were generally also tin bronze. I'm going to skip that. Okay, so I think it's clear that a much more expanded, more comprehensive and systematic investigation of full assemblages, not just the final products of put in graves, including metallography, elemental analyses, lead isotope, has great potential to contribute importantly to the study of early metallurgy, not just of interest to Thailand and Southeast Asia, but for the global study of early metallurgical systems. Okay, since I only have 5 minutes, I'm just going to kind of skip through this. One of the most important things that has emerged from the work in Thailand since the Boncheng excavations in the mid-1970s is this extraordinary sub-regional variability of pottery. And in my view, this is the most important thing to study going forward. We have highly distinctive pottery types. You get a pot like this, you know it's from the Bansheng general area. You have a pot like this, you know it's from the Kawang Pachon Valley. This is a very signature aspect of Thailand's Middle Age history. So we put a lot of work into sorting out the Bansheng pottery, and particularly during something called the Year of Ceramics, with help from the Luce Foundation, we were able to do an in-depth study of the Bansheng pottery. All kinds of that money and other money allowed a really meaningful ceramic analysis. We had courses, students studied Bansheng pots, we had a postdoc, it was great. And Jum is here? Where's Jum? There, Jum came and was with us as one of the as the Thai intern to participate. So we were able to use a variety of techniques, including radiography, scanning electron microscopy. We were able to look at forming techniques in great detail, how the pots were made. We have a wonderful database on each pot, database information. This doesn't give you, I mean, more than, I don't know, a few hundred observations on every pot. This is a view of the storage area at the basement or the sub-basement of Penn Museum, where the pottery is stored. And I'm just going to give you a snapshot of one burial. It was our most well-endowed burial with 24 pots from the middle period. We had 6 different shapes and 5 different fabrics, including one non-local fabric. And interestingly, let me go back. Okay. Those white carinated pots were made with 2 different fabrics. So that suggests 2 different potting communities. So that hyperbolic type, they wanted a white color, but there are 2 ways of getting it. One way was simply through the choice of clay and the firing control, it fired white. But another way, they used an iron-rich clay but put a white slip on it, among other things. So it's very interesting. We can start identifying different potting communities. And I'd just like to point out, this is essentially like social networks. So that barrel 20 had connections with numerous potting communities that contributed to the pots that she was ultimately interred with. Okay, so just one very quick thing. I hope you've gotten an appreciation for how important it is to get materials from in situ contexts if we want to really understand the past. And I was recently, or not recently, in 2005, I was asked by the US Justice Department to help them in an investigation of smuggling of Bansheng and other Thai prehistoric artifacts. And if you want to really hear about this, if you're in Bangkok on June 3rd, I'm going to give a full presentation on that case at 10 a.m. at the National Museum. So everybody in Bangkok, please come. It's funny, it's sad. It's not every day does an archaeologist get to work with a very different kind of culture and try to make a difference in this area. And I was involved in the search warrant of this particular museum that had, all these pots, not a label, everything taken out of context. It was just very, very sad for me. So please come. And I'm going to give you just this one sense of the scale of damage. That adze with Vulcan was the only adze excavated by the Penn projects in the mid-70s in 640 cubic meters of excavation. The main smuggler, had over 250 copper alloy adzes, and more than 300 were seized in this case. So multiply the Bansheng excavations by 300, and you get a sense of a vague sense of how much has been destroyed in Southeast Asia, in Thailand, from just this one smuggling operation. I think we just all need to keep in mind that, like fossil fuels, archaeological resources are non-renewable. 20 years ago, a publication by the National Geographic said, if the present rate of archaeological destruction continues, there may be no more sites to preserve in much of the rest of the world in 50 to 100 years. Because archaeological sites form an irreplaceable resource, we who are alive today are responsible for saving this valuable record, and archaeologists must sound the warning. If we do not meet this obligation, the incomplete knowledge gained up to now and in the very near future must suffice for the rest of time. So, be thinking about what you can do. Don't buy antiquities, and so forth. The situation is dire. Thank you very much. It was wonderful to have this opportunity to speak with you. Thank you.